So we'll first talk about how to lexicalize a tree bank. We'll then give definitions of lexicalized PCFGs. We'll talk about parameter estimation in these models, and we'll actually make direct use of the smoothing techniques we saw for language modeling in the first lecture from this class. We'll talk also about parsing with these models. And then finally, I'll talk a bit about accuracy of these models, comparing, for example, to PCFGs, and going into some depth about how we actually evaluate different parsing models. Okay, so the first key idea in lexicalized PCFGs is to add annotations specifying what's called the head of each rule in a context-free grammar. So I've shown you a simple grammar here, and I'm going to assume that the rules fall into two types. We either have some part of speech, rewriting as a word, or we have some non-terminal rewriting as a sequence of non-terminals, which could be non-terminals like a prepositional phrase or parts of speech like VI or VT. The key idea is going to be for each rule in the grammar to identify one of the children of that rule as what's called the head of that rule. So I've used red to denote the head of each rule. So VP is the head of S, VI is the head of VP, VT is the head of VP, and so on. So we're choosing one of the children to be the head of the rule, and so this is in some sense an additional piece of information in our context-free grammar. We don't just have the rules, we also have annotations specifying the heads. So that's the abstract idea. Let me talk a little bit more about where it comes from. It's actually a core idea in linguistics. This idea of heads in rules goes back to very, very early work in linguistics. Some intuitions. In some sense, the head is sort of the core of the rule. It's the most important part. So a verb phrase, for example, will always have some verb on the right-hand side of the rule, whether it's an intransitive verb or transitive or ditransitive verb. And this verb is in some sense the semantic center of that rule. It's the most important part of the rule. Similarly, for an S, you can argue that the VP is sort of the semantic center of that rule, as the predicate in the rule. And also for these noun phrases, the rightmost noun is again the most important part of the rule. So these head annotations are actually often not present in tree banks, and they certainly weren't present in the Penn Wall Street Journal tree bank, which was the tree bank used for many of the original experiments in statistical parsing. And so these annotations have to be recovered with a set of rules. So let me give you some examples of how we might do this. This is an example for noun phrases of a set of deterministic rules which will recover the head for each noun phrase. For example, they would make these annotations I've just shown you down here. So the first rule says that if the rule contains a singular noun, a plural noun, or a proper noun, then choose the rightmost of those nouns. So that would apply to these two rules here. They both contain one of these three categories, in which case we just return the rightmost category as being the head of that rule. If this fails, however, we go on to the next rule, which says that if the rule contains an NP, choose the leftmost NP. So this is going to apply to cases like the following. If I have a structure like that, it doesn't contain one of these three categories. It does, however, contain an NP, and in that case we take the leftmost NP as the head. That's this rule down here. Those are by far the most common cases. Most noun phrases, at least in the Wall Street Journal tree bank, have either one of these three categories or a noun phrase on the right-hand side of the rule. But there are some funny corner cases, and so we go through a few of these cases here. If the rule contains a JJ, this is an adjective, choose the rightmost JJ. There are some rather strange noun phrases which are composed, which don't contain nouns but do contain adjectives. CD is a number. This is something like 100 or 1,000 or something like this. And then finally we just have some default rules saying we choose the rightmost child under the noun phrase. Here's a second example. This is an example for verb phrases, specifying a set of rules which recover the heads of verb phrases. And they're rather similar to what I showed you before. The first rule says that if the rule contains an intransitive verb or a transitive verb, choose the leftmost VI or VT. So that would be this here. In fact, we'd probably be careful to specify all verb categories here. There might be several different subcategories of verb. On the other hand, if the rule contains a VP, choose the leftmost VP. Okay, so if we have a structure like the following, then this rule fails, the VP doesn't dominate the VI or VT, and instead in this case we just choose the leftmost VP as the head of the rule. And finally we have a default case just saying if we don't find any of these categories, just choose the leftmost child. So why are we doing this? The main motivation is going to be the following. In a moment I'll show how once we have these annotations of heads in rules, we can use them to propagate lexical information up through the tree. So we will actually transform our tree bank from these kind of structures, which are kind of vanilla PCFG structures with rules such as NP, S goes to NP, VP. And we're going to add lexical information in the tree. In particular, for each non-terminal in the tree, for example, here we have VP, we'll now add a lexical item, questioned, which is drawn from somewhere below it in the subtree. So the question came from this word down here. And the head annotations will be used to define how head words flow up through the tree. So in one sense, you can just view these new structures as as a new set of non-terminals. So whereas before I had non-terminals like S or VP, now I have non-terminals like S questioned or NP lawyer. So there might be around 50 non-terminals in my original grammar. In this new grammar, I have 50 non-terminals times the vocabulary size. So it could easily be in the thousands of non-terminals. But in a formal sense, nothing has changed. We've just vastly increased the number of non-terminals in the grammar. You can see that by adding this lexical information to these non-terminals higher in the tree, it will allow us to be more sensitive to lexical information at higher levels in the tree. And that's going to be the key idea in these lexicalized PCFGs. This is how we make the PCFGs more sensitive to lexical information. So how's this process performed? Let's again look at this example. The critical idea is to propagate lexical items bottom up through the tree, where each constituent receives its head word from its head child. So let's look at this tree in a little bit more detail. The first case is simple. Whenever I have a part of speech, for example DT, we simply get its lexical head, its lexical item, from the word below it. So this just goes straight up. And so each of these parts of speech just immediately receives the head word from the word below. I should have said, by the way, these words are often referred to as head words. The head word of a constituent. Now let's go a little higher in the tree. Let's take this noun phrase here. So for this noun phrase we have the following rule. NP goes to determiner NN. And let's assume that our head rules have identified NN as the head of that particular rule. Well, our rules for propagating lexical items up through trees say that words are propagated from the head to the parent. And so witness, for example, is propagated up through the tree like this. So this noun phrase receives its head word from its head child in the rule. Similarly, if we look at VP goes to VT NP, let's say for the sake of argument that VT has been identified as the head of this rule, that means that this VP gets the word questioned from that. We have a similar step here. And finally, if we have S goes to NP VP, let's assume that the VP is the head, and so this lexical item gets propagated up through here. So it's really very simple. We propagate lexical items bottom up through these trees using these head annotations, where each non-terminal receives its head word from its head child. And the final result is we've transformed our trees in a way that each non-terminal now includes lexical information taken from the subtree below it.